Hello, everyone. We're going to go ahead and get started on section 2.1, which is covering frequency distributions. Let's go ahead and begin by discussing what are some key terms that we need in order to begin discussing these frequency distributions. So just some definitions listed here. And these are just taken right out of your textbook. An ordered array is an ordered list of data from largest to smallest or vice versa. So it is simply our data that we have sorted. If you go into Excel, for example, and you have all the data, you can just highlight the column that you're in and then sort A to Z. And then that would give you an ordered array. A distribution is a way to describe the structure of a particular data set or population. A frequency distribution, note that this is this section's title, is a display of the values that occur in a data set and how often each value or range of values occurs. If each category represents a single value, then the distribution is referred to as an ungrouped frequency distribution. Otherwise, in each category represents a range of values, then it is a grouped frequency distribution. So if your frequency distribution is simply looking at the data values, say 1, 2, 3, 4, and how many times each of those shows up, that's ungrouped. If it has a range of them and it lets you know how many fit into that range, then that is a grouped frequency distribution. The frequencies, which are represented by little f, are the number of data values in the categories of a frequency distribution, and a class is a category of data in a frequency distribution. Okay, so let's go ahead and discuss how can we go about constructing a frequency distribution. Now, there are a few things that we need to be concerned with here. Our first thing that we should be concerned about is decide how many classes should be in the distribution. So decide how many classes will be present. In general, we prefer to have, as just an arbitrary rule, approximately 5 to 20. It's possible that having fewer or more is going to be desirable here, but whichever of this range is going to be a bit up to personal preference here. Then our second one is to choose or define an appropriate class width. Now, what this means is, well, how wide do we want our class width to be? And in general, the best way for us to do this is to just take our max data value minus our min data value divided by our number of classes. And then we'll, in general, round up to whatever level of precision we're looking at in our data, okay? That will help to determine how big each of our classes should be. And then 3, we should go about finding our class limits. Find or define our class limits. So when we are talking about class limits, what we mean are our lower and upper class limits. Those just define our range of our class. Okay, so what you want is you want our class limits to have a reasonable number of each of our data values will be present in here. So you need to use your best judgment. You should choose your first lower limit to have the same number of decimal places as the largest number of decimal places in the data, so you aren't going to get more precise than your data indicate. Once you choose your lower limit, then you'll add your class width to that, and then that will get you your your lower limit of your next class, and then you'll define your upper limit of the previous class to be just below that to within what are called class boundaries. We'll talk about those in a second. After you have all of your classes, then you'll just go about listing what the frequency is for each of those. Do make sure that all of your data are present within these classes that you have defined, okay? And then number 4, this is pretty straightforward. Determine or find the frequency. This was that little f that I talked about of each class. Okay. And again, as I mentioned, your class limits should have the same number of decimal places as the largest number of decimal places in the data. What that generally means is if your data goes to the nearest 100th, let's say, then your class limits should go to the 100th. It can go less precise, but it should not go more precise. Okay. So as I mentioned, and let me just go ahead and give you these definitions here. I have alluded to them, but let's make them official. The class width is the difference between the lower limits or upper limits of 2 consecutive classes. So it's just the lower class limit of 1 minus the lower class limit of the one above, or the upper class limit minus the other upper class limit. Totally fine for those. The lower class limit is the smallest number that belongs to a class. Upper limit is the largest number that can belong to that class. Okay. So let's go ahead and suppose that we are tasked with finding a frequency distribution from this data here, or these data. Okay. I recommend you go ahead and pause the video so that you can get all of this data written down, and then we'll go about constructing our frequency distributions from that. Okay, so here we were told that we needed 7 classes. So what I'm going to do is I'm going to look for the largest data value. Well, noting here, these are going in increasing order. My largest data value is my 82,700. I will subtract my minimum data value, which is 50,700. And then I'm going to divide by my number of classes. They indicated there were 7, so divide by 7. I plug that into my calculator and I get that this is approximately 4,571.43. Okay. Now, we can define the level of precision that we're looking at here. If I do take a look, it appears as though my level of precision is to the hundreds place. I don't see any data values that are non-zero after the hundreds place. So I'm going to go ahead and round this to 4,600, making sure to round up to make sure that I get all of my data. If you round down, then you will not be guaranteed that you get all of your data within your groups here. Okay. So I can go ahead and choose 4,600. Totally reasonable for me to make use of this class width. If you chose a different class width, that's totally fine. There's a bit of leniency here when we are defining these. Now, if you want to make this look even better, you might say, well, 4,600, that's not great. What if we did 5,000? If you did 5,000, totally fine. Same basic idea here. Okay. Now, if I take a look, what I need to do now is figure out what are my class limits going to be, starting with my lowest class limit of my lowest data value. So my lowest data value is 50,700. So what I'm going to do is I'm going to have my classes and my frequencies, and let's see if we can construct these. Now, if I'm looking at 50,700, you can choose any starting point that really makes sense. I'm going to choose, say, 50,000 because it will include my bottom data point. You could have done 50,500. You could have done 50,200. But I think that this is the most reasonable place to start if I am choosing this 5,000 class limit. Now, Adding 5,000 to this, because that is my class width that I've discussed, will give me 55,000 here, 60,000, 65,000. And these are just my lower class limits. So I'm just looking at what is my lower class limit, adding that for each of these. 75,000. And I note that my data goes until 82,700. So I'm going to need 80,000 will be my last lower class limit. Now I'm going to be going until I am just under this. Which one am I going to pick? Well, to my level of precision, I'm going to say 54, or oops, just that here, 54,999. Now, it might be more precise, but in general, we want to avoid being more precise than what's listed here, which is to our ones place here. And this is going to go to 59,999, 64,999, 69,999, 74,999, 79,999, and 84,999. Okay. So I have defined my classes. So now what I can do is I can take a look at my data here, and I'll figure out how many are going to belong to each class. Well, if I take a look here, for 50,000 to 54,900, I have 1, 2, 3. So my frequency here is 3 for my first class. For my next one, 55,000 to 59,000. You'll note there's nothing in here. That's going to give me a frequency of 0. That's okay. You will expect for a decent number of these, for your frequencies, you'll end up with 0. That does not mean exclude it. You should have that present even if the class is empty. Then continuing on, 60,000 to 64,99, I have 1, 2, 3, 4, 5, 6 in here. And then 65 to 69,999. I see 1, 2, 3, 4. 70 to 74,999. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. And then 79,601 and 82,701. This is my frequency distribution. Now note, when you do have a frequency distribution in general, you should provide a title for it. So in the context of this, this is highest salaries for entry-level bachelor's or bachelor degree recipients. Okay. And this is what our frequency distribution looks like here. Okay. Hopefully this makes sense to everybody so far. Then moving on, the next thing I want to discuss is our concept of a class boundary. Okay, so a class boundary, and actually, let me just paste this directly from my notes so I won't need to have you attempt to decipher my awful handwriting. A class boundary is the value that lies halfway between the upper limit of one class and the lower limit of the next class. After finding the class boundary, add the class width to find the next class boundary. Class boundaries are typically given in the interval form: left parentheses, lower boundary, right parentheses, upper boundary. Okay. So if we were looking at these here and I wanted to find, hey, what are my class boundaries? The trick for these is you can go ahead and add this and divide by 2, and that's totally fine. That will get you there. So you could take 50,000 plus 54,999, divide that by 2, you get 104,999 divided by 2 would get you 54,999. The other way that you can do this, and this is for class boundaries, is just look at the level of precision that you have. You'll note here this goes to the ones place. So what I'm going to do is I'm just going to check what's the next place. The next place after the ones place is the tenths place. Increment or decrement by 5 in that place. Okay, so what I'm going to do here is I'm going to subtract 5 in the tenths place from 50,000. That's going to get me 49,999.5 up to 54,999 plus 0.5 in the next one. So plus 0.5. Do the same thing for all of these. So I'm going to have 54,999.5 to 59,999.5. And you'll see that this and this are the same. But hopefully this makes sense. If you do have questions about this, please do let me know. But all I'm looking for here is the level of precision that I am given, which here was in the ones, then go to the tenths. So if your data were, for example, in the tenths place, you could express it by looking at the hundredths place and going from there, okay? And it continues like that. Your exercise is to go ahead and figure out what each of those would be, okay? Now, if you want to find the class midpoint, the class midpoint is simply the average of our lower and our upper limits. Okay. Now, if you are paying attention here, you'll also note, hey, if I'm looking at my lower limit and my upper limit, well, if my lower limit went down by 0.5, my upper limit went up by 0.5, those cancel out. So another formula for this could be your lower boundary plus upper boundary over 2. This one also works. So using whichever you prefer is going to work just fine here. Okay. So if I wanted to find the class midpoint of this example here, I would just take my 50,000 plus my 54,999 divided by 2. Now I could also use my class boundaries, as I mentioned. I could use these here. It's going to be the same thing either way, so it's up to you. And I find that I get 52,499.5. Okay. Now, if you want to find the class midpoints for the other classes, you can make use of this formula. However, if you want to save yourself a decent bit of time, just add your class width. Okay, so if I wanted to know what is my class midpoint of this one here, I can calculate it by adding these up, dividing by 2. And that's totally fine. If you want to do that, knock yourselves out. But if you want to save yourself a bit of time, just add the class width here. Class width was 5,000, so I could do 57,499.5. Now my next one would be 62,499.5. Again, all I'm doing to get that is I'm just adding my class width of 5,000. And this is showing me what these class midpoints are for each of these. Again, you can make use of the formula if you want to for these. You're not wrong if you do that. You could put that into Excel and automate that. Totally fine. Totally straightforward way of doing it. However, as a wise man once said, a good mathematician is lazy. Okay. So that's how we go about finding our class midpoints for each of the classes that are present. Okay. The next concept I should mention is the concept of relative frequency. So relative frequency is the fraction. Now this is sometimes given as a percentage, but you can just convert that directly of the data values don't know what happened there with that S. Data values that lie in a class. Given by the formula, my relative frequency equals F over N, where F, this is my class frequency, N, this is my sample size. Now, if you're not sure what your sample size is, your sample size is just the sum of your frequencies. So you just add up all of your frequencies of each class. Okay, now a little bit of notation that your textbook makes use of here. It uses a symbol like this here. This is the Greek capital letter sigma. And sigma just means add. So for this, you could say the sum of f sub I. And this would just add up all of the frequencies of the I classes. This would be like I equals 1 to k if there are k classes. So it adds the frequency of the first one, the second one, the third one, and so on until you reach the kth class. Okay, so note that if they're showing you that, then this is just a way of representing this. Okay. Now, what are the relative frequencies of the example that I provided earlier? Okay, so for these here, let me go ahead and just screenshot this so that I can work with it. Here. Okay, so if I am taking a look at these here, first, what I'm going to do is I'm going to find out what is my total frequency or my sample size. So 3 plus 6 is 9, 13, 23, 24, 25. So 25 is my cumulative frequency. To find my relative frequency, I'm just going to divide each of these by 25. So I'm going to take 3 divided by 25, which is going to get me 0.12. Now, if you want to convert that to a percent, knock yourself out. 2 places to the right is 12%. 0 divided by 25 is 0. 6 divided by 25 is 0.24, 0.16, 0.4, 0.04, 0.04. If you're wondering how I'm doing these, I'm just checking to see what multiplies to give me 25. The answer is 4, so I can just multiply these by 0.4. That gives me these here. Okay. So all I'm doing for these is I am just dividing them by 25. 6 divided by 25 is 0.24. 4 divided by 25 is 0.16, and so on. And that's it. That's how I calculate those relative frequencies. Okay. So I did throw in a term there that I should probably define. I mentioned 25. I called this the cumulative frequency. The cumulative frequency is simply the sum of the frequencies of all of our classes, or rather of all previous classes. Let me be a bit careful here. So if I am talking about the cumulative frequency of this class here, it is 3 because there are 3 here and total of 3 up to this point. For here, still 3. Then my next one here is 9. Okay, so my cumulative frequency is simply adding this up. So 3, that's all I have. 3 plus 0 is 3. 3 plus 6 is 9. 9 plus 4 is 13. 13 plus 10 is 23. 23 plus 1 is 24. 24 plus 1 is 25. And I see that I have a grand total of 25 for my cumulative frequency in my last class. You should note the cumulative frequency of your last class should be equal to your sample size. Okay. Hopefully this answers any questions that you might have about this section. If you do want to see more examples, just let me know. I'm more than willing to record more examples. Otherwise, I will see you in the next video.